Okay, so we will be working on lab 2 right now. So this is a lab 6 global surface temperature. As I have already told you in my previous presentation video, that we will be talking about solar constant. That is one of the factor. We will be talking about albedo, and we will be talking about greenhouse gases. So these are the three things you will be uh, given some brief idea about those things. So as usual, there will be short video by Mila. Don't forget to watch that, the beginning of the lab. So okay, so then one moment, why is not my mouse is working now? Okay, so let's see. Okay, so there will be three types of question: fact-based question, synthesis-based question, and hypothesis. Fact-based. This lab asks lots of facts-based questions, so be careful about that because it has to be perfectly accurate because the answer is already there. Synthesis, the answer is there already, but it's not directly stated. You need to figure it out. And for the hypothesis, the answer is neither stated, not there, but the answer evolves around the whole overall idea, your own discretion, your own understanding. So that's one more thing. Mhm. Okay, so let's go to the question. So at the beginning, you will be asked some given some description about the solar spectrum, ultraviolet, visible, and these are the stuffs. I'm sure you already know that. Then sunspots. So the question will be asked, and also in change in solar constant. So let me okay, so let me tell you that one in very brief details because you should all, I'm sure you already know that you need to study those description which will help you to answer the question. So solar constant are caused by changes in the number of sunspots from year to year with an average and a 11-year period between peaks in sunspot numbers. So if you look at this figure, just when you are going through the description, you will know what I'm talking about. So the changes in solar constant, because solar constant change in solar constant depends on the number of sunspots and other stuff, and the number of sunspot has a cycle, so it continues for every 11 year. So right now the number of sunspots right now we are having in 2022, uh, in 2023 it will be different, 24 it will be even more different, and after 11 years, that means in 2033, you will get the same number of sunspots like that in 2022. So that has an 11-year cycle. So even if you look at these graph, you see there is a pattern that you can see, this pattern, and then again this one did the same types of things, then again this one did the same types of things. So like you can see from this portion is almost similar to this portion. So if you look at the age gap, time gap of them, so this is from 1979 to 1990, so that's 11 year. Then again from 1991 to, if you look at another 11 year, 2001 or 2002, kind of similar. So that solar constant has an 11-year cycle. Keep that in mind. There will be question asked about that. So even if you look at that in here, you can understand some of the questions or some of the idea. So what things appear on the sun to increase solar output and cause the solar constant to not be constant? So you already know the answer is already here. So then the question asked about the albedo. So you know the highest albedo, you know the lowest albedo. The white body will have highest albedo. The black blackish body will have lowest albedo. Even if you look at this figure, you can see the object which has the highest albedo, the object which has the lowest albedo. So just follow the number and answer question 2 and 3. Okay, then there will be question 4 that is being asked based on this video. Watch that video. And last semester when I was taking this course, one of my student, she told me a really interesting point that mm, I had no idea about that by that time. So what she said is that when you go to an area that has like that going when you go near to the pole, like near to the Antarctic region or Arctic region, the place where there's lots of snowfall, lots of ice up there, you need to wear more sunscreen than than you are in a tropical region. You need to wear more sunscreen in an icy area. Why is that? When she introduced me, when she told me about that fact, I didn't have any idea about when sunscreen is needed. But when she told me that, then I got the point. Like I already told you that ice already reflects back most of the energy, almost 85 or 90% of the energy. That means when the solar radiation is coming towards the ice, sorry, there is a sound outside. I'm not sure what's that for. It's already 4 in the morning, so sometimes I get scared. So the idea was that is when the sun emits, because the ice actually reflects back 80% of the energy. Even you can see from this thumbnail, reflects 80% of the sun's energy. So if they are reflecting it back, that means they are going through the atmosphere, through the air around you, right? So if you are already there, that means those emitted energy will probably impact your skin. So that's why you need to wear more sunscreen. So that really made sense, and that was really really interesting information for me. Then answer that question 4 based on the video. I'm not going to talk to you about that at all. And then just view the animation. Here there's an animation about the greenhouse effect. Follow the graph. You saw that the carbon dioxide concentration have increased from 1750 to till now. So it's going on increasing and increasing. So that's one of the vital information you need to know. Then there is greenhouse gases radiative forcing from 1750 to 2011. So if you look at the nitrogen dioxide, if you look at it, just open this one. Nitrogen dioxide, ozone, tropospheric ozone. This is ozone depleting substance, methane, and carbon dioxide. So you can see that the radiative forcing, carbon dioxide has the highest number of radiative forcing among all other greenhouse gases. So you can understand which one are the greenhouse gases we are talking about, and among them carbon dioxide has the highest radiative forcing, not because in terms of its power but in terms of its quantity. So when you'll go through the description, you will be able to understand what I'm talking about. What types of radiation is absorbed and emitted by gases as part of the greenhouse effect? So what types of these? And then question 6, what types of radiation is absorbed and emitted by gases as part of the greenhouse gas effect? So just see these things. I'm not going to talk to you about that. It's all in the description. So just follow the description and answer the question. Then question 6, which greenhouse gas had the highest radiative forcing? So you already know. Section 3 that talked about the Earth's energy balance. I already discussed that in the presentation video. 341 is coming, incoming solar radiation. Among them, 161 is absorbed by the surface and 23 is reflected by the surface. And when it is coming, 78 is actually absorbed the atmosphere, and 79 was actually reflected by the clouds and atmosphere, and rest of them came back in here. So this was the pretty much brief idea about that. And when it was trying to go out, so yeah, they took an intersection of the point in here, and it went tried to go out. Among those 396, 40 were went out through the atmospheric window, 356 were trapped in, and they actually reflected back 333, which is called the back radiation. So those are the idea of these figure. Just follow the information. And what is the source of 341? I'm sure you will be able to understand, answer this question 789. I'm not going to talk to you about that at all, because you already should have the idea from this graph, from my description in the presentation, from my description right now. So definitely you will be able to answer these three questions as well. Then again, this is the last part, last main part, because rest of the question will be asked based on one simple Microsoft Excel file. So this instruction is really really easy. So what you need to do from section 4, you need to download a temperature model Microsoft Excel file, which downloads a file in here. You need to open that and follow the instruction as it says. So go forward, and what it says, black body earth. So let me open the Microsoft Excel file. Click enable editing, enable editing. So okay, so what it says, let me see. So you will first land on a worksheet labeled 1 black body. So what do you need to do? You need to go to black body, then see what it says. Solar constant is 1365. You will be assuming throughout this exercise that the solar constant never changes. Keep that in mind. Solar constant never changes. For us, for this lab, for the purpose of this lab, for now, solar constant is always 1365. It will never change, but it changed over time. But for now, for this lab, you will see, you will consider solar constant to be 1365. There's no change about that. So there's a question about that. Keep that in mind. This is our main and base assumption, that solar constant doesn't change. So, okay, so there will be question about that. What is the solar constant for earth that is used throughout this exercise? Yeah, I already told you. And please power the units. The unit is watt per square meter. What is the Earth's albedo when Earth is portrayed as a black body without an atmosphere? So answer it from here. So if Earth is a black body, I already told you black body is the perfect absorber. So it absorbs everything, it reflects nothing, which means that it doesn't have any albedo when it is a black body. So if it doesn't have an albedo, so it should be what you know already, I believe that. Then you need to go to question surface, like it will be given, the instruction is already there. Go to slide 2, surface albedo. So okay, so you do it here. Okay, then you need to go to surface albedo and put the information here. So the idea is that, you see, I will show you how to go about that, and then and I'll show you some crucial information in this Microsoft Excel sheet. Just all you need to do is to go down and down. Just when it says go to surface albedo, number 2, go to surface albedo. When it says go to surface features, go to surface features, number 3. Then when it says go to total albedo, go to total albedo. So this is pretty much simple. So all the answers from here on, I don't need to explain anything to you, because all the answers are there for sure. There's no confusion, I'm sure, if you have followed the instruction properly. So what I'm gonna do, I'm gonna just take you through these all slides, all the Excel worksheets, and tell you if there is anything that I need to mention. So for black body, there's nothing you need to input, because this already given. Then for surface albedo, you need to input these, fill up this yellow cell. So incoming solar radiation is shown as 184. So that is the summation of 161 plus 23, that is 184. Then what is the reflected by surface? So the surface reflected by, so 161 is already absorbed, so the reflected one is different, and you can see that from here. So you need to put that information in here, which will calculate the surface albedo, and you will get a new value. Then if you go to the number 3, so albedo, okay, so this one, When you calculated these in the question tab 2, it will be automatically updated, and it will be updated as well. So there's nothing I need to mention. Then uh, number 4, if you go to number 4, total albedo, again you need to fill up this information. Based on this information, it will calculate you for you the earth's albedo. So incoming solar radiation, this is the incoming solar radiation, 341.3 or 341, whatever it is. Then reflected by clouds and atmosphere, follow with the clouds and atmosphere. There's the clouds and atmosphere. And then reflected by the surface, there is a reflected by the surface. So put those information in here, you will get a value. Answer the question, whatever it asks. Then go to question 5. So there is this one, the hash that you're seeing right now. It will come from the previous tab, so you don't need to do anything about that. All you need to do is to fill up this information in the yellow cell. In fact, this hash will also be calculated from the previous tab. So all you need to do is to fill up this information. To fill this up, you need to click here. There is a link to find the current carbon dioxide concentration. Just put that concentration over here, it will calculate something for you. So the current carbon dioxide concentration is from January 2022. They didn't update that for this month. It will be updated soon, but you can use this number, 417.99. And then put the information in here, follow the digit and question. Then go to 6, lgm albedo. What it says, the last glacial maximum. So you need to know what is last glacial maximum. You already studied those things in your theory, I'm sure. So what it said, actually range is in albedo, the during the last glacial maximum, water albedo was around 0.03 to 0.07. Then there is forest, desert, snow, and ice. So it asks you to put the number in here. You can use the minimum number, you can use the maximum number, but I would rather prefer you to put the average number in here. So for water, I will probably put 0.05, that is in between these two numbers, 0.03 and 0.07. For forest, I will put 0.15, that is between these here. For desert, I will put 0.40 in here, and for snow and ice, I will probably put 0.75. So it's up to you, but this is how I would have done that. Either way, it will be okay for you, but try not to use the extreme number, not the minimum, not the maximum. Try to be around the mid range. That will actually give you very good approximation of your question. There is 6, then it will tell you to go to 7, carbon dioxide. So there is a carbon dioxide chart. So the concentration is there in terms of ppm, and the number is also there, and this is the time. So there you need to know 3 point here. So 1 point is the carbon dioxide concentration during the lgm, last glacial maximum, because you need that information. So for lgm in here, you can see the carbon dioxide concentration was really low, below 200, and then in 2010 it became almost 390. Then in 2050 it will be from 500 to 520. That means it is 510 ppm. So you need to input those information in the next tab and answer the question. So number 8 tab is asking about the lgm. So you already know the lgm, during lgm period carbon dioxide concentration was below 200. Put that in here, and it will update accordingly. Then if you go to the 2050, put 2050 carbon dioxide concentration that I've already talked about. From tab 7, 2050 concentration, put that in number 9. It will give you some value definitely. That's it. That's what you need to do. Just input all those information and follow the question, follow the instruction, and input everything according to that. And it will ask some question, why is that, why is not that, why is that number, what is that number, what is the albedo. So it will be there already. So all you need to do is to fill out those information, and this lab is really enjoyable for you if you understand, or if you actually paid more attention to the description as well as my video instruction and everything. I wish you all the best, and see you next week. Let me know if you have any question. Thank you.